Q6621-1. The rotor RPM may momentarily increase during the flare portion of a flare-type autorotation. This increase in rotor RPM is due to A. An increased downwash velocity. B. A decrease in rotor drag brought about by a lack of forward motion. C. The additional lift derived from the increased angle of attack of the main rotor disc. The correct answer is C. During a flare in a flare-type autorotation, the pilot increases the angle of attack of the main rotor blades by pulling up on the collective or cyclic control. This increased angle of attack generates additional lift, which helps to slow down the descent rate and cushion the landing. As the angle of attack increases, the rotor blades generate more lift, causing an increase in the rotor RPM. This increase in RPM is a result of the additional lift produced by the blades as they bite into the air at a higher angle of attack. Q7088, which is true about an autorotative descent. A. Generally, only the cyclic control is used to make turns. B. Collective pitch should be used to control rate of descent. C. Rotor RPM will tend to decrease if a tight turn is made with a heavily loaded helicopter. The correct answer is A. During an autorotative descent, the helicopter's engine is not providing power to the rotor system, and the rotor blades are being driven solely by the upward flow of air through the rotor disc. In this situation, the collective pitch control becomes ineffective in controlling the rate of descent because adjusting the collective pitch has no impact on the power output of the engine, since it is not running. Therefore, the primary control for making turns during an autorotative descent is the cyclic control. The cyclic control is used to adjust the pitch of the rotor blades as they rotate around the rotor disc. By tilting the rotor disc in a specific direction, the pilot can change the direction of the helicopter and initiate turns. The cyclic control allows the pilot to adjust the lift generated by the rotor blades in different parts of the rotor disc. By increasing the lift on one side of the rotor disc and decreasing it on the other, the helicopter can be tilted and turned. The pilot can manipulate the cyclic control to roll the helicopter into a turn and maintain control throughout the autorotative descent. Q7053. During the full flare portion of a power-off landing, the rotor RPM tends to A. Increase initially. B. Decrease initially. C. Decrease during high-density altitude days and increase during low-density altitude days. The correct answer is A. During a power-off landing, the helicopter is descending without engine power, and the pilot needs to manage the rate of descent and control the helicopter's descent profile for a safe landing. The full flare portion is the final phase of the landing where the pilot reduces the descent rate and transitions to a smooth touchdown. As the helicopter enters the full flare portion, the pilot raises the collective pitch to increase the angle of attack of the rotor blades. This action increases the lift generated by the rotor system and slows down the rate of descent. By increasing the collective pitch, the pilot effectively increases the demand for lift from the rotor blades. When the collective pitch is increased, it creates a higher demand for power from the rotor system. To meet this demand, the rotor RPM tends to increase initially. The increased rotor RPM helps maintain the required rotor lift to support the helicopter during the full flare maneuver. By initially increasing the rotor RPM, the pilot ensures that there is enough rotational energy in the rotor system to provide the necessary lift and control authority during the full flare and touchdown phase of the power-off landing. Q7066. If complete power failure occurs while at cruising altitude, the collective pitch should be lowered, as necessary, to A. Uncouple the main rotor system from the engine. B. Engage the freewheeling unit so that proper rotor RPM can be maintained. C. Reduce the pitch on all main rotor blades so that proper rotor RPM can be maintained. The correct answer is C. In the event of a complete power failure during cruising altitude, the helicopter's engine is no longer providing power to the rotor system. As a result, The rotor blades rely on their stored rotational energy to maintain rotor RPM and provide lift for a controlled descent. Lowering the collective pitch reduces the angle of attack of the rotor blades. By reducing the pitch on all main rotor blades, the pilot decreases the demand for lift from the rotor system. This is important because the rotor blades are now operating solely on their stored energy, and excessive demands for lift could cause the rotor RPM to decrease rapidly. Maintaining proper rotor RPM is crucial for rotor system efficiency and maintaining control of the helicopter during autorotation, which is the controlled descent without engine power. By reducing the pitch on all main rotor blades, the pilot ensures that the rotor RPM remains within the appropriate range for a safe descent. Lowering the collective pitch also helps in reducing the overall drag on the rotor system, allowing the stored rotational energy to be used more efficiently in maintaining rotor RPM and controlling the descent. 7078-1. When auto-rotating during high-density altitude or strong gusty wind conditions, a slightly higher than normal airspeed is recommended because the resulting slower rate of descent will allow more time for the pilot to estimate the touchdown point. B. Resulting glide angle will approximate that of a slightly reduced airspeed under conditions of light loads, low-density altitude, or calm wind. C. Lower rotor speed will cause the rate of descent to approximate that of a slightly increased rotor speed under conditions of light loads, low-density altitude, or calm wind. The correct answer is B. Autorotation is a controlled descent maneuver used in helicopters when there is a loss of engine power. During autorotation, the rotor blades are driven by the upward flow of air through the rotor disc, providing lift and allowing the helicopter to descend in a controlled manner. In high-density altitude or strong gusty wind conditions, the air density and wind conditions can affect the performance of the autorotation. These conditions can lead to reduced lift and altered glide characteristics. By maintaining a slightly higher than normal airspeed during autorotation in such conditions, the pilot can compensate for the reduced lift and altered glide characteristics. A higher airspeed helps to counteract the effects of high-density altitude or strong gusty winds and allows the helicopter to maintain a more desirable glide angle. The resulting glide angle at a slightly higher airspeed will approximate that of a slightly reduced airspeed under conditions of light loads, low-density altitude, or calm wind. This means that the helicopter will descend at a rate similar to what would be expected under more favorable conditions, providing better control and allowing the pilot to estimate the touchdown point more accurately.